Okay. So plan for today is we're gonna do a couple problems on this worksheet together, and then the rest of it, you guys are actually gonna, in Polaris in a few minutes, find a slideshow that I put in there that has all of your parent function projects in it. You're gonna use the parent functions from yourself and from some other groups from you guys in 8th period to fill out all of the properties for all of our parent functions. Okay, so that'll be the majority of the period, but there's a couple things we want to do together on this first. So you do have a Math Excel also for 2-6. It's short. I think it's just like 8 questions. That is going to be due on tomorrow night. But again, just like 8 questions, none of the graphing stuff, just a couple questions about piecewise functions and then this kind of stuff. All right, so first type that you're going to see on Math Excel is going to look like the example at the top there. It says write a linear function for the indicated values where g of -2 is 2 and g of 1 is 8. So we actually know how to do this problem. They're just giving it to us in a different form with this function notation. When you're given function notation, what's inside the parentheses? Always an x, and what's outside the parentheses? In function notation, a, y. Yep. So you have an x and a y twice. 2 points. -2, 2, and 1, 8. I will get the door. All right, so all I have to do is find a linear equation, which just means an equation of a line between these 2 points, which we know how to do. What's the first thing we do? Find the slope. y2 minus y1 over x2 minus x1. And I get 6 over 3, which gives me a slope of 2. Once I have a slope, how do I get the y-intercept? Plug them in to y equals mx plus b. So y equals mx plus b, my slope is 2. And then you can use either set of points. I'll use 1, 8. X is 1. Y is 8. So b will equal 6 when I solve for b. Final answer, it said write a function, and they told us the name of the function. The function is function g. So instead of y in your final answer, make sure you write g of x equals mx plus b, which is 2x plus 6. Okay, so just instead of a y, we're using that function notation for that one. Okay, questions there? Yes. If they give you the name of the function, you need to use it. If they don't do that, if it just says write the equation of a line and it doesn't say function or anything like that, you can put whatever you want. Y is fine. Okay, anything else on that one? All right, so flip it to the back. The only other thing I want to do together is at the very bottom of the back. So the greatest integer function is one that I did not assign any groups because it's a little tricky to look at. So the greatest integer function, there's going to be a number inside what looks like a double bracket. And what it means is we are finding the greatest integer less than or equal to something, which is a fancy way of just saying round down. Whatever number is inside those double brackets, okay? So if I want to take my greatest integer function, and this is what it looks like, and I want to plug in 3.5, it would look like this, okay? And I round down to the integer that's closest to it. So what integer is below 3.5 that's closest to 3.5? 3. Okay, and that's it. So even if I had like 3.9, it would be 3. Be careful with negatives. Remember, when you're rounding down, think about like a number line. We're always going to the left on the number line when we're rounding down. So what integer would be to the left of -4.9 on a number line? -5. Oops, -5. Okay, so that's how the greatest integer function works. What ends up happening is a whole range of values all round down to the same thing. So like anything between 3 and 4 will round down to 3. Anything between 4 and 5 will round down to 4. Anything between 1 and 2 will all round down to 1. So we get what looks like little stairs in the graph. Anything between 1 and 2 rounds to 1. So I see a little horizontal line at 1. Anything between 2 and 3 rounds down to 2, so we see a little horizontal line at 3. If I'm exactly at 2, it rounds to itself. If I'm exactly at 3, I see an open circle then, because that's where it jumps to the next integer. And if you do your vertical line test, it'll pass the vertical line test, okay? So that's what our function looks like. So now naming properties of it. What's the first one at the top there? Increasing, decreasing, constant. Is there anywhere where this graph is increasing? Decreasing? Constant? Yes, it is constant. And I'm just going to say we're not going to use interval notation. Usually we do, but it's kind of tricky with this one. So we're just going to say constant between consecutive integers, meaning any two integers that are next to each other, we're going to have a little horizontal line between them. So between 1 and 2, 2 and 3, 3 and 4, forever. Okay. Next question it's asking is even, odd, or neither? So even, could I reflect it over the y-axis and it look the same? No. Odd, can I flip it upside down and it look the same? Look at this little line segment right there, just that guy. If I flipped it upside down, where would it end up at? Would it end up at the same spot? No. Where's that little line segment going to end up at? Would it end up over here on the other side if I flip my paper upside down? So just that little guy alone, you can look at it and say, it's not going to be the same. It's going to be in a different spot on the graph. So even, odd, neither, this guy's a neither. Okay, what's the next question on there? Domain and range. Okay, domain. Is there any x value I can't plug in? Nope, domain is all real numbers. It's easy. Range. What kind of y values do we get out of this equation? Whole numbers, a little more specific, integers. Okay, and again, that's the only one we're not going to really write in interval notation because it's just all of our integers. Positive and negative whole numbers are integers. What's the last question? Intercepts. Do I have any xy intercepts? Okay, so I have a y-intercept where? At 0. X-intercept. I have a few of them, right? Anything that's on that x-axis. So I'm going to use interval notation here. I'm going to say from 0 with a bracket all the way to 1. 1 is not an x-intercept, though, because there's an open circle there. Okay? Anything else? No, I think that's good. Okay. And then remember, little horizontal line segments are considered minimums and maximums. So actually, every point on this graph is a min and a max. Okay, so here's what I need you to do. 2 graphs are missing on your paper. On the front, at the very bottom, I want you to write the exponential function. Add that to the bottom, the exponential function. And then on the top of the back page, we're going to add the logarithmic function, log equation. Okay. So the rest of the period is yours to fill out the remaining properties for all of our parent functions. So what I need you to do is go into Polaris. If you find our WAG, you can just click on parent function project. Okay, parent function slideshow for the day. It'll take you to it. I put everybody's project in there. If something was not correct, I fixed it. So all of the information in the slideshow is correct. And there's multiple projects for each function, but they are in the same order as what's on your paper. So the first one you guys are going to see is the constant function, which is the one I actually have on the board. After that, you're going to see a couple identity functions. You can pick which one you want to look at, zoom in, whatever you want. You just got to get all of your properties filled out, okay? And then whatever time you have left at the end of the period, you guys can work on that 2-6 Math Excel that's due tomorrow night. Good? Good. All right, go ahead and get started.